Good morning, my YouTube viewers. It is Crystal here, and I wanted to do another code review for you. This code review I'm going to do is going to be the naive Bayes classifier with JAX, and we're going to be using the breast cancer data set. The reason why I'm using JAX is because it's a relatively new library, and it's slated to take over TensorFlow for research purposes anyway. But the thing about JAX is it doesn't have these inbuilt models. You have to make the models yourself. So you get closer to the computer with JAX than you do with Keras TensorFlow and with sklearn. And so we're going to be using the toy data set with sklearn, which is the breast cancer data set. And so we've written this program in Google Colab, which is a free online Jupyter notebook hosted by Google. And JAX, as well as TensorFlow, are libraries that have been developed by Google as well. So the problem with Google Colab is it does not have a very good undo function, so you have to be very careful not to accidentally delete or overwrite valuable code. I have done that before. I have messed up the code before and the code didn't save, and then I had to completely try to remember what I did and then completely rewrite it. So that's something that I have done in the past. So after we have created our Jupyter notebook, we import the libraries. And so the libraries we're going to use are JAX, which is very similar to NumPy, only it's more powerful than NumPy, and jax.numpy as JNP, which is very similar to NumPy. Most of the commands in JAX NumPy are close to, if not exactly the same as NumPy, so that's good. So this is also a good way to become more familiar with NumPy when you're using JAX NumPy. We're going to use sklearn datasets, and we're going to use the breast cancer dataset, and we're going to use sklearn train test split as well. So the first thing we want to do is we want to set the seed. So key equals jax.random.prng key 42. So that's your key, that's your random number. Then we're going to define the variables. So our variables are our metric equals Gaussian. So that's your variable. Then we're going to load the data set, and that says iris. It shouldn't be iris, it should be breast cancer. Load the breast cancer data set. Data equals datasets.load breast cancer. X equals data.data. Y equals data.target. We're going to print x.shape. It's 569 rows by 30 columns. We're going to unique counts equals JNP unique Y, return counts equals true. So we print unique, which is 0 and 1, and we print counts, which is 2, 12, and 3, 5, 7. Then we're going to use sklearn to split the data set up into training and validation, training and testing sets. And then we're going to check the shape of these sets as well. So, and then what we're going to do is we're going to code the naive Bayes algorithm. So the first thing you have is you have your class naive Bayes, and then you got your def in it, which is a function. And what you're going to do is you're going to initialize everything. And so def init takes self, x, y, metric equals Gaussian, use log equals false. So self.x JNP equals JNP array x. self.y equals JNP array y, self.data equals JNP dot concatenate self.x, self.y, reshape -1, 1, axis equals 1, self.inFeatures equals self.xShape 1, self.classes equals set y. So the classes are going to be, you're going to create a set, and it's only going to be 2 classes in this instance. Self.inClasses equals len self.classes, so that's the length of self.classes. Assert metric in Gaussian, and it says invalid metric. Self.metric equals metric, and self.uselog equals uselog. Now we have a function called fit, and when the fit is you're going to train your data. So def fit self, self.summary is an empty dictionary for I and self.classes. D equals self.data, self.data, it's going to be all the rows and -1, so that's your y variable, equals I. Mean equals JNP.mean. D axis equals 0, that's your rows, and it's all of the rows except for in the last column, which is your y variable. STD equals JNP.std, and it's going to be D, and then axis equals 0 is rows, and it's going to be all the rows and the last column, which is your y variable. L equals len D. Self.summary I equals mean, the mean, STD, the STD, and len is L. So that's your training. Now what we're going to do is we're going to get the probability, def get probability, it's going to be self, it's going to be INP, I think that's input, mean, and STD is standard deviation. If self.metric equals Gaussian, which it does because we set it up for Gaussian, exponent equals JNP.x, it's going to be negative INP minus mean squared over 2 times the standard deviation squared. And then res, I think that's like a result, equals 1 over JNP dot square root 2 times JNP dot pi times STD times exponent. And then if self.uselog, and that it is self.uselog because I think it's set to true. I think it is set to true. No, it's set to false. Then return JNP.log 1 plus res, but the self.uselog is false, so it's going to turn res, which is your result, I think. And now what we're going to do is we got the final function, which is predict, and it's going to be self x. So self is like your model. So assert self.summary classifier not fit yet, and then results equals an empty list for INP in X. Pred class equals -1. Pred prob equals 0 for I and self classes. Probs equals self.get probability INP, self summary I mean, comma, self summary I STD. Class prob equals JNP.prob probs. If class prob is greater than pred prob, pred class equals 1, pred prob equals class prob. Results.append pred class. So you're going to append the pred class to the results, and it's going to return the results. So those are your functions that we're going to use with the naive-Bayes classifier. So now we're going to set it in action. Model equals naive-Bayes. X train, Y train, metric, uselog equals true. And then we're going to fit the model. And then so when you fit the model, that means you're training it. And so now we're going to get the predictions. YPRED equals model.predict x test. Print elim for elim in YPRED. So that's element for element in YPRED. And then so what I did was I made it all print out in one horizontal row instead of the vertical row that it previously had been done. And that's why I did that. Now we're going to calculate accuracy. So we've got another little function to calculate the accuracy. So correct equals 0 for I in range len actual. If actual I equals predicted I, correct equals correct plus 1. Return correct over float len actual times 100. So now we use that function. Accuracy equals accuracy metric y test y pred. Print accuracy, so it's 94.7%. Now what we're going to do is we're going to compare it with sklearn, because sklearn has a Gaussian NB function. And so when we compared it with sklearn, we had a 93% or really a 94% accuracy. And then we made predictions on it. And this is we predicted on X test. We compared our accuracy again, and we got a 94.15% accuracy using sklearn and a 94.73% accuracy using JAX. So that tells you that JAX performed better than sklearn. So that was good. That was a good code review. I didn't use any visualization, but I could have used visualization. So let's see here. Let's set this up to 2. Test size equals 0.2. Okay. And then let's say so we're going to import Seaborn as SNS. So your label is your target. So we're going to make a histogram. And then we're going to do the kernel density estimator. So let's see what happens. And so I changed my test set to 20% instead of 30%. So we'll see what happens. And the good thing about using sklearn datasets is you don't have to find a dataset. It's there already. So you can see we've got more ones than we do zeros. So what that means is that there's more people with cancer than non-cancer. And then when we set our test data set to 0.2, we've got an accuracy of 97.36. And the accuracy on sklearn was 97.36 as well. So that means that sklearn performed exactly the same as JAX. But this is a good way to learn JAX and learn machine learning is to do all of these algorithms by scratch. I mean, sklearn is a great library to learn machine learning with, but if you really want to learn the code and you want to learn the algorithms, then you've got to get in and study the actual code that makes the models. So that's what we've done. And to conclude, when we had a test size of 20%, the accuracy of JAX was exactly the same as the accuracy of sklearn. So I'm going to go ahead and conclude this code review because we covered all of the information that we want to cover. I would like to thank my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you if you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching this video. I look forward to making more videos for you in the future.